Hello, welcome to the version 3 of Branon, the IoT controlled load operator, or rather remote controlled load operator for domestic as well as commercial purposes. So today I will just introduce the new version of Branon that has been enhanced with a few more features than the previous version. The first thing that makes a difference here is the ESP node MCU, which has been included in the present design. This was not there in the previous designs. We used to communicate using GPRS. So in the new version we have included the Wi-Fi and removed the GPRS communication. So those who need the GPRS can buy the previous version, and the new version comes with a Wi-Fi node MCU. Here is the node MCU. It's connected using DuPont wires. So this node MCU will communicate over any standard Wi-Fi router at 2.4 gigahertz frequency bandwidth. Additional features in this particular board specifically includes 4 static loads, that is over here. Previously there were 8 static loads, so the number of loads has been decreased to 4. The RS485 Modbus communication is still there, so it's a 2-wire communication. There are a set of LED indicators to help you understand, like if there's a system fault, if there is a Bluetooth communication or a Wi-Fi communication. When the Wi-Fi is connected to the server, there's an indication. If the IoT is working properly or the IoT communication is going on properly, this LED will help you know that. There are also options for CPU thermal overheat indication and server error. If in case your server returns some error value, then you will have this LED lit on, and this run LED will let you know that your device is running properly, and this is RS485 or Modbus communication indicator. This is the reset chip, the reset button which resets the system microcontroller. The entire system as of now for version 3 is dependent on an MSP430 F5XX series. So that's a huge code memory space of 128 KB and a system RAM of around 16 KB. And few more additional features is that if you can just have a look, we have another small microcontroller on board which is also an MSP. It is MSP G series, that is the value line series. So basically this microcontroller helps any kind of remove any kind of flickering that can happen in the final load output stage over here. If the main processor undergoes any kind of system reset due to any problem, maybe your watchdog problem or stack crash issue or power brownout problem, so in these cases the smaller microcontroller will still keep on holding the loads at their required values, so you won't have any flickering at the output even when the system resets. And there are a set of pins which you can see from here maybe. These set of pins are basically analog input which you can interface to your system if you need to connect some kind of industrial application to this. So these there are in total around 20 analog input channels, and also some digital output, digital input channels which you can use for your own purposes. There are 2 variable load connectors over here. One is VL1 as you can see, and the other is VL2. So you have 2 variable loads. If you want to connect 2 variable loads, you can connect, else you can just connect one or even connect none of them. And now coming to the overall display of the system. So this is the overall mechanical display. Here we have the variable load unit, which is basically a track based AC load controller. You can connect any motor with this or any dimmer. And this is a 7-inch TFT LCD, which is just an optional. You can have a 5-inch connected to it, 3.5-inch, 7-inch, or you can even omit the LCD. It's completely optional. So let me first just power on the device. So here I have powered on the device, and you can see that this is the initial screen that you will be having when you switch on the device. Now I want to show you some salient features of this particular design. The system clock over here, this can be updated directly from the server. or the IoT platform web page, or the UI, the web UI, and that I will be showing you right now. And also, apart from this, there is only one menu page, unlike the previous one. So in this menu page, basically you just have some very few settings. You have the brightness control, which was also there. I can increase the brightness. You can say the baud rate for your RS485 communication, and you can also enter the Wi-Fi name, that is the name of the SSID, what as we know, and the password for the Wi-Fi. So I will just show you how to change the Wi-Fi and password over here. Now the Wi-Fi details will be saved inside the EEPROM. So once you enter the correct detail, and if the system is able to connect into the Wi-Fi system, then these values will be saved into its EEPROM memory, and when you switch it on the next time, or even if there is a power failure, you don't have to re-enter the values over and over again. But there is, the scanning system has been purposefully disabled because these systems are to be connected with a very specific router or access points, so you have to enter the complete name of the SSID you want to connect the device to. Okay, now coming to the the PC part of this device, as we can see over here that there's an USB port, a fully USB version 2 port connected with a board, and from there you can have complete system logs. So I have just connected the USB port of my computer to the USB AB mini port of the Branon. So here I have a you can use putty, you can use teraterm, but I am using H term for this. So once I press connect, the system will give me the complete logs for the running of the device. Okay. So since this device is already running, so I just want to show you from the beginning that what logs come. So let me just reset the device. So I have just reset the device, and here you can see these are the logs that will be coming, that it is just it is reading the EEPROM. You can have some ESP logs, and also the state machine that the ESP in, as we have implemented state machine control for the ESP over here. So you can also have the state machine state directly printed on the logs. And as you can see over here that we have a RTC update. Here we have the RTC update. So specifically you can just follow over here, as I will just show you for one particular log cycle, that over here we are giving the AP details which are being printed, and this is the entire get JSON that is returned from the server. So all the details that you need to know, all the details that you need for debugging, you can have from this log, and if required you can also add on to the log for any particular function you want. So this is the complete log functionality. So now let me go to the main website. So this is the main website for the device. Now one thing first we have to make sure is that the device is operating in IoT priority mode. Okay, so here let me go to the settings page, and in the settings page I will just show you, this is the IoT priority setting. Okay, so here you have to make sure that this is not in local priority, this is in IoT priority, and just set on that, so that will be automatically fed back to the device. So once your IoT is in priority, so then you can make any change from this website and get that reflected onto the device. Now since the device has been switched on for the first time, just see that the time which is being shown over here, which is supposed to be the actual device time and not your system time, so this time is coming in a very wrong format. This is just because the particular RTC values hasn't been set. So what we need to do is we just go to the option called device time set. in device time set, we just click and we have a date time picker that will appear. So in the date time picker, you just select today. So this today will copy your computer system time, and which is supposed to be correct, and then you just click on the button set. Now you have to wait for some time, and now let us see what happens in the device. In the device, you have to wait for the next get cycle. So once the get cycle happens, there will be a green arrow over here, which is happening right now, and after it reads the time which has been set in the server properly, you will see set time over here, and then the time will be updated over here. As you can see, it has been updated as the time that we had given as 10:57 p.m. So now frankly speaking, this time will be updated thrice. This is just because the system is under maintenance or under debugging. So when you operate it in the normal mode, you just have to set it once and it will read it and it will reset the bit on the UI. So after one complete particular cycle, you can again reset the time, but it is recommended that you set the time once, because there will be a battery or a supercapacitor on the board that will be holding the time count even when the device is switched off. Another unique feature which I should show is the device IP address that is being reflected over here. This is the actual device IP address which it has received from the router. So using this particular IP address, you can like ping in your local network and do like any kind of activity or network communication checkup or any kind of diagnostics that you want to do. Now let me go back to the main page, and as you can see, since the IoT is in priority, as soon as I say I want to switch on load number 2, so when I switch on load number 2, then now load number 2 over here is off. One thing you have to remember, that load 2 on website is basically load 1 over here. So load 1 is off, which is load 2 over here. So when we switch it on and press the button submit, okay, so we just keep it very short, and within around 10 to 15 seconds the entire system should update it. So we are just waiting for the next get cycle, which will be evident with a green arrow. So as soon as the next get cycle happens, you will have the update. So we have to wait for the next get cycle. Here is the get cycle that is happening, and just after the get cycle finishes, you can see that load 1 is turned on. So I can just turn on maybe another load, or maybe turn off load number 1 and just press on submit. It's a very simple operation, but I just want to show that the delay which was there in the GPRS is not there here anymore. So here again, like I have just set it off rather, and immediately within say a few seconds the load here is turned off. So let me just check it out with some another property. That is, say if you want to say change the power of the fan to any value, say I want to change it to 10%, which means that I have changed the speed of the fan, and that should be reflected over here, and you can see it is immediately changed to 10. So now the updates are being taken very fast and it's almost instantaneous. Let me make another difference. Let me just switch off load number 2 and just press on the submit button. So once it is submitted, I will have to just wait for another get cycle. So the get cycle is the green arrow, as I told you. So just when the green arrow will be shown, the get cycle will operate and it will fetch the data from the server. So let us wait for the next get cycle. Here it is, and here you will see that, see here the load was switched off. So basically if you follow my previous video, the functionalities that were described over there are same, just the fact that the response has been made very fast and the system time can be updated as we can see over here, it is now showing the exact system time and temperature. The system time will be updated directly from the web UI. Also, one thing more we need to see is the Wi-Fi or the device operator, which was showing the same operator previously, will show Wi-Fi over here. It will not show the network to which you are connected or the SSID to which you are connected. The SSID will be shown when the connection happens for the first time over here. So like these are the main changes that has been done to Branon, and the system has become much more reliable, much more fast, much more we can say intelligent or smart, because now it can calculate if it is not being able to connect to any Wi-Fi network, and it can reconnect to that network. And another basic feature that I want to show you is, in case if you want to change the Wi-Fi network, you just click over here, and here you can enter the name you want of your network and just press on OK. Similarly for password also, you can just change the password you want to change, and you just press on the button OK, and just click on save ID and click on save password. Once both the buttons become green, it means that they have been saved internally, so you don't have to worry like if it is saved inside or not. And if you want to see it in under system log, you can see that when we had typed the ID and the SSID and the password, here the SSID will also come in the log, and the password will also come in the log here, AP key, which is shown over here. So you can also see in your log if the values are being fed internally properly, and I guess it's a better one. It's working fine, and it's a more smoother and faster responsive system than before. We're still working on some more features to add on that we will finalize within maybe around 10-15 days. So that is it till now. Thank you.